Thank you for joining our ETRAGE webinar. Today, I am joined by one of our partners, CadActive. Since 2016, they have been helping design and manufacturing companies improve their design processes using PTC's Creo. Today, they are here to share how to make life easier for many designers through automation, and in particular, Creo cabling. Some housekeeping notes at the beginning. Everyone is muted, so we ask you to use that Q&A icon for questions, and we'll answer those towards the end of today's session. Though we do encourage you to share your questions at any time, so just go ahead and type those in as they come up. A recording of today's webinar will be available, so everyone registered will receive a link via email. I'm Sinead from ETRAGE, and joining me today is Phil and Ben from CadActive. All three of us have spent the last 10 plus years in the PTC and manufacturing space. And as you will hear, we work to find ways to automate tasks and processes to assist folks like all of you in getting your products to market faster. As you see from the posted agenda, I will do a brief introduction of our organizations, and then I'll hand things over to Phil, who will talk you through the benefits of being able to add automation through your Creo cabling. And then Ben will show us how those benefits are put into action through a demo, and then we'll be able to get to your questions and answers. So, who is ETRAGE and who is CadActive? ETRAGE is a global company with over 20 years of experience helping PLM adoption extend beyond engineering and across your entire manufacturing enterprise. We do this by addressing the needs of your systems, your management, and your end users. We understand that adoption is not a one-time event, but an ongoing strategic process, and it's evolving as your business evolves. CadActive is a North American reseller of PTC software. By combining industry insights with their technical expertise, they create custom solutions that streamline engineers' daily workflows. Their specialty is PTC Creo, and with a special emphasis on Creo cabling and piping. So again, we do encourage you to ask those questions today. ETRAGE and CadActive work together to support PLM adoption from CAD to PLM to pushing data into your ERP and shop floor viewers. As software developers and service providers, we can fill those gaps in your digital thread. ETRAGE is continually expanding our suite of products and services, and that's because folks like you come to us and tell us your problems, and we create solutions for those real life problems. And those solutions end up helping other companies who have the same or similar problems. CadActive over the years have also done similar things for CAD-based solutions. And so with that, Phil, I'll hand things over to you so that you can show an example of how you guys have implemented real life solutions to real life problems.
Yeah, so I'm just going to quickly run through just a high level why this whole discussion is important and give a little bit of context. And then Ben's going to jump into a little bit more of a detailed demonstration of how we might be able to help you guys with your Creo cabling. This is definitely a deep subject. There's a lot of topics that we can cover within it. So to the extent that anybody wants to connect after the call, we're certainly happy to talk through any of this. So just to kind of get started, I think I want to highlight what the typical approach to cabling in Creo looks like, right? And this is just what we've seen as through lines with all the customers that we end up talking to, right? You might have some 2D schematic concept design, right, that lays out your bill of materials and the components that are going into your model, right? You also might do some sort of detailed design on in terms of electrical components, right? You might route your cables, you might place connectors, you might just leave space for those in your model, right? But typically what we see in terms of like downstream deliverables are in fabrication, where you're ordering a cable or ordering components, you are doing that based on your ECAD definition, right? Because this has that full list of components that you need. And then same thing, you might use a wire list or equipment list that also might come from the ECAD side of things. So just to quickly highlight on the design side of things, again, typical things that we see, right? Some teams use intelligent ECAD tools that have metadata that is exportable. Very rarely do we see folks have a connected process where that 2D concept design is driving the 3D design. We also see teams that use tools that are more like what we refer to as like lines on a paper, right? There's not really any exportable data with it. It's showing the diagram itself, the connectivity diagram, and then that's manually used downstream, right? And so the problem with this, right, is that there is no spatial awareness of how the cables might be routed, where they fit, if they go around this corner properly, right? So, you know, we see a lot of companies getting real creative with how they determine line lengths, whether that's just in a first article, you know, doing some rough measurements, whether they're, you know, sort of hacking it in the Creo side of things and building something that's not necessarily reusable, but shows the space claim. They might fudge the design a little bit, right? Then also on the 3D design side of things, I think there's a lot of reasons why folks don't route cables in 3D. It's hard to do. We're going to get into that a little bit at the end, but this kind of results in cabling happening at the end of the process, right? You kind of need your model to be mostly created in order to understand how the cables are going to route through it. But a lot of companies are shortcutting this 3D detailed design for electrical today. So why is it hard to work with 3D cabling design? I'm hoping that folks on the call will be able to relate to this, right? Number one, just the CAD platform capability. The programs themselves struggle to deliver a product that, unless used properly, works well, right? And even when they do, the learning curve to execute on that design is steep. And on the design side of things, we're already strapped for time. If leveraging the 2D schematic works for your downstream deliverables and you figured out this process and it's been in place for many years, it's hard to change, right? Mostly because that value recognition happens downstream. You know, if we build better 3D cabling models, there are benefits downstream, which we'll cover. But the design teams aren't necessarily seeing that as a benefit for them. It's more of an extra thing on your plate, right? And so what this results in are folks and companies not changing, staying at status quo. If they do go and tackle 3D cabling design, maybe one or two experts know how to do it. That creates bottlenecks, that creates scalability issues. And at the end of the day, it devalues your 3D digital product definition. And so what are some of those delays and why is this a problem at the end of the day, right? If we're not building great 3D designs, well, we might not understand that cable fits where we think that it fits. The bend radius might not comply to the way that we think it would, right? This is basically just going to create rework. And the later that we discover this rework, the more expensive it is for the team, right? We ordered a custom cable, it wasn't the right length. We either have to fix it or order a new one. Maybe you had the wrong equipment in the diagram or in the model. right? We can't run digital validation accurately. We can't do any clearance or creepage analysis. We can't really create work instructions that show that 3D representation, right? We're just using the 2D schematic. So it creates a lot of challenges downstream. And then I think what we would propose and what we see as best practice would be connecting that 2D concept design with your 3D detailed design and leveraging that 3D detailed design as the source of truth for manufacturing. And this is basically the other side of the coin, right? We know that we order the right stuff on the first try every single time. We uncover issues with our product earlier in the process. We remove late stage rework. We allow for, Industry 4.0 and cutting edge technology like model-based, like digital work instructions, right? We can use that 3D definition for a lot of things. And I'm certainly flying through here, but yeah. So how do we do it, right? So CadActive is a company that can help you guys modernize your electrical design, right? And there's a few ways that we think about that. Number one is to take that 2D data and connect it with the rest of your organization, right? Natively, Creo Parametric can ingest Creo schematics files, but it's rare that we come across a company that's using Creo schematics today, right? So there's kind of a decision point there where you say, do we need to change our whole ECAD tool? Or is there a way for us to integrate, say, like a Capital Harness or an ePlan or a Zukin into Creo, right? And that's something that we've helped a lot of companies with, right? Is not having to uproot that whole schematic design process, but still being able to leverage that intelligence in the 3D model. Then on the 3D side of things, there's typically an implementation effort with Creo cabling, right? And that just means setting up your design strategy, right? The thing with cabling is that it has to happen in context of a larger assembly. So we kind of got to do things right so that the model doesn't break and you don't have performance issues or crashes, and so that you can feasibly actually perform the design, right? We need to create standard catalogs and components and spools that might match your schematic components so that Creo knows what it's ingesting from the schematic design, right? Once we get that kind of like standard environment in place, then we can go and take those rules and those standards and that infrastructure and apply automation to it, right? We've made a lot of the decisions about this electrical design on the schematic side. We know the connectivity of the diagram. We know what's going from what component to what component. We know what spools are connecting them. We know what connectors are in the model, right? So our belief is that you shouldn't have to remake those decisions on the 3D side. We should be able to leverage that data in a more automated way to create your 3D models, right? And then once you have that fully defined 3D Creo cabling model, we can go and report on it and leverage it downstream to actually derive the value that we're looking for, from this whole process. So why does an automated approach make sense? Number one, right? We're kind of removing this steep learning curve for 3D cabling design, right? We're minimizing the resource strain, right? So that you don't have to add on resources in order to implement this new capability, right? We're stopping bottlenecks, right? Like I said earlier, a lot of times when folks implement Creo cabling, it ends up being one or two experts that know how to do it. That's risky for a company. That creates issues in the long run. And we want to make this approachable for the common designer, right? And again, like I said, most of the work's already been done on the ECAD side of things. So if we can automate this, we can recognize those company level benefits of 3D cabling design without really needing to slow down or add on extra resources, right? That's why automation makes sense. And that's all I had to show. So certainly high level, I think we want to talk to you guys a little bit about some of the tools that we have created within Creo cabling, and I'm going to pass it over to Ben for that.
There we go. So here we have a model of an electrical cabinet, and first thing I'll do here is switch to a simplified rep so that we can see things a little bit better. Basically, where we're at right now, we have our connectors and everything assembled into this model, but we have nothing in the way of like a harness part. We have no network. We have no. We actually don't even have the spool files in here or anything like that. So the goal of this demonstration is to do all of that, right? Create what we consider to be a best practice. This doesn't have to be the way that it works, but this is just the way that I'm set up to work with it. I'm going to create a subassembly that contains my harness, and it's also going to contain a skeleton model with all of the copy geometries and all of the references that are needed to create that harness. So for anybody that's not familiar with skeleton models or copy geometries, it's just a reference management tool within Creo, a way to reference copies of geometry instead of the source geometry so that you can minimize those, the size and the time that it takes to calculate your references, right? It's just better for model performance, and it can help to reduce errors in your model tree by being more conscious of the references that you're making. So again, just from a high level, we are going to create an electrical, like a routing subassembly here. We're going to have a skeleton model in that with all the references we need. And then we're going to create a harness part and route a bunch of wires inside of this cabinet. All right, so with the CadActive application, you just get this extra tab here for CadActive that has all of our tools within it. I am specifically going to be looking at cabling and our cabling auto routing here. The ribbon is context sensitive, so you're going to see different buttons up here depending on if you have a part open or an assembly open or a drawing open, or if you actually are in the cabling application. If you have that application active, you'd see different things in this ribbon as well. Just like Creo itself, right? You see different things in the ribbon when you have different things open and you're in different contexts. But now, the reason why I bring that up, I don't even have the cabling application active right now, and I'm still able to access our auto routing tool and do all of this cabling work without even turning on the cabling application. So this is our auto routing GUI that's going to pop open here. I can either select an assembly that's already existing, or I can choose to create one on the fly here, which is what I'm going to do. I'm going to follow a standard naming convention here, and my top level assembly, as you can kind of see up here, is elec_cabinet. So I'm going to name this elec cabinet routing, and it's going to have all my routing information in it. So you can see a bunch of stuff happening down here in the message log. And once this finishes creating, I'll show you what we actually just did. Should be about done here. There we go. All right. So here is our subassembly that was created. Inside of it, I have a skeleton model, like I mentioned. If I look in that skeleton model, it has a whole bunch of stuff in here that just got created while we were waiting. So all of these are grouped by model, by component specifically. And then inside, like if I open one of these groups, it has a whole bunch of copy geometries of all of the relevant things from that model. So in this case, CMO1 is a connector here. It has a whole bunch of entry port coordinate systems. Each one of those got its own copy geometry here. And specifically, these are external copy geometries. Again, that's just something that we consider to be a best practice. All of this stuff is configurable. You can make this in whatever way you need it, but by default, this is what we consider to be a best practice, is these external copy geometries. We also created a harness part inside of here. And for right now, that harness part, we have some like temporary, a temporary wire feature and a temporary spool that we put in here. But essentially, this harness part is empty for the time being. The next thing that I need to do is go find my input file. So here I have my autoroutingdemo.xml. That has information about a whole bunch of different wires that we want to go route. And then before, whoops, there we go.
And that might come from your ECAD tool, right? Whatever it is, whether it's schematics or Zukin or ePlan or whatever, right? We'd expect that to be a direct export from your ECAD tool.
Yep.
Yeah.
So before I actually hit go on this, I'm going to flip over to this routing settings tab. So in here, we have a whole bunch of different, essentially, there are some different algorithms that we can use to solve for the path, the like A to B path that we want to use. Here's a list of the different algorithms that we offer. I'm going to pick this one. Then there are a bunch of these different variables that control how hard the algorithm is supposed to work, right? Do we want it to be, it's kind of a seesaw, a balance of, we want it to work hard enough to give us a good result, but if we crank all of these variables way up, it's going to work really, really, really hard. It's going to take more time, and we might see a minimal benefit as to like finding the right balance for these. That would be a part of an implementation process. These values may be different for different companies based on the models and their particular use case. So as a part of implementation, we would usually do kind of a study and do some tests with different values being used for these different variables and find a sweet spot where it's like, okay, we can live with the amount of time that this is taking, and the results that we're getting are pretty good. So I'll just tweak a couple of these. There's a whole bunch of these settings, but like I said, this is something that would be honed in on from the jump, like as a part of implementing this. And this is not really something that an end user would ever have to worry about again. We also have the capability to save profiles into, there's a web application portion of this. So you can save different profiles and like different values for the settings within those profiles. The idea there being that maybe you have a first pass and a second pass, right? So you do, your first pass is a little bit rougher, but it runs really fast. So you run your first pass, and that's good enough for 90-95% of your wires or cables that you're routing. But then there's a couple that maybe don't look as good as you wanted. You can just go specifically to those 2 or 3 wires, whatever it is, and change their routing profile to be second pass or whatever you want to call it. And now just on those couple that need the extra calculation to be done, they can take a little bit longer for just those few, but now we're not waiting on the entire model to have those same routing settings on everything. All right, with that being said, let's go ahead and click OK. So while this is evaluating, I do want to talk a little bit more about that input file. Like Phil mentioned, this is something that's going to come from your ECAD tool. As long as you have an ECAD tool that is intelligent and you can export information from that tool, that's typically good enough. If we can get information out, we can get that out and do what we need to do to get that into a format that we can work with. So of course we work with Creo schematics, obviously. But like, for example, this XML file that I'm looking at or using in this example, this is a format that we got out of AutoCAD Electrical. So yeah, again, I guess just one more time, the ECAD tool that you're using does not matter. We can take any sort of format and get it into this tool and use it to auto route these wires. And then another thing that I would say about this, so I'm running it manually right now. Like, I'm actually clicking the buttons and saying okay and feeding in the input file. We also can run this in batch. We can run it in non-graphical mode. You can have a worker machine that's just set up with some listeners, and as orders come in, it populates a file in a certain folder, and that kicks off an event where that worker machine now spins up Creo in non-graphical, opens the model, runs auto routing with the input file, saves it, and stores it in a different location. And all of that can happen without the interaction of a user. And then maybe you just, if you have a user interact with it, maybe they just pop it open, make sure it looks good, verify, and send it on. So a lot of different ways that we can use this tool and set it up. We can automate it more or less depending on what you need. There we go. And now we're done. So this went through and routed all of these wires. If we look in the harness part now, we can see there's a lot more features in here than when we first started. I have the settings on here set up in a way where it's creating a bunch of these point features. This is really, I have it set up because I think it's worth showing here. Like, this is kind of showing the points that are being evaluated by the algorithm. And then finally, this final point feature. This is the points that are actually being used as cabling locations to create the route, the shape of this route. So like I said, I have my settings so that it creates all of these. These are the things that are being evaluated no matter what, but I can turn that off, and essentially what I would get would be just my wire feature and then one point cloud feature that contains all of the points that are being referenced. Just to show another, I think this one's a good example. Let's see. Yeah. So like, this is a good example of how the algorithm is being used, right? You can see all of these points that are being considered and used for the routing. But yeah, that is really the main point of the demo. So if we were to take a step back and again, just summarize from a high level, what did we do? In that short amount of time, we created this good structure that we consider to be a best practice, right? We're not relying on people to remember exactly how we want this to be set up. It's all driven by the automation. We've created that subassembly with our good structure. We've built out a skeleton model with all of these different copy geometry references that we want to use for our harness. And then, of course, we've created our harness part and routed all these wires. I'll point out there is no network in here. So each one of these wires is being, the path is being solved by the algorithm. It is creating those points per wire and then routing the wire along the points in that point cloud feature. One other thing that I'll point out here as well, just a final point. The way that we are working with this in this demo, the connectors themselves are not inside of this subassembly. That's just the way that I have it set up to be working right now in this environment. That does not have to be the way this works, right? We can set this up to not happen within a subassembly at all if that's the structure that you need. We can set it up so that the connectors are brought inside of that subassembly. And we can actually use another tool of ours called AutoAssemble that can be kind of rolled into the auto routing process, where you supply an input file, you say go, and before it starts solving for these paths, we can have it actually assemble all of the connectors and the electrical equipment that you want first, right? So instead of having this stuff already sitting there, we could have assembled our connectors, designated them, and then created all the wires and routed them. So just a couple different options. Like I said, it's very configurable. There are a lot of different ways that we can set this thing up to work depending on the use case. But yeah, with that being said, I think we can probably pass the ball back and move on to some Q&A.
Yeah, I would think just in terms of use cases, like Ben said, we've done some really high volume use cases in like command line, non-graphical mode with this. We could run this in like, point-to-point wiring, kind of like you see here. We could run it with, a complex cable and take bundle width into account. We could run it with a complex harness that has different branches on it. Again, I think the one of the points that Ben has touched on a few times here is that we're offering an off-the-shelf application here, but it never looks the same for two customers. We typically tend to configure it on a customer-to-customer basis so that we get it in place. We know that it works the way that you want it to work, and then we let you, run with it. Yeah.
Yeah, you don't have to fit into our structure. We'll fit into your structure.
Exactly. Yeah.
All right. Well, thank you, Ben, and thank you, Phil. If you do have any questions at this time, go ahead and utilize that Q&A icon. While we wait for those questions to come in, I'm going to try to share my screen one more time. Okay. I just want to go through some of the up and coming events that ETRAGE has. Our next few webinars will continue to look at PTC topics. So next month we'll be covering Creo tricks and tips, or tips and tricks. And then we'll be looking at Microsoft desktop integration with Windchill. At the end of April, CadActive and ETRAGE will be attending the annual PTC User Group Summit, which will be happening in Las Vegas. So if any of you are attending, please stop by and say hi. We'd love to talk to you. So let's see, it looks like we have a couple of questions. Let's see, so the first one is, how about splices? Can those also be added automatically, or they need to be placed before routing the wires?
Yes, so we do have people that are using splices, or we also have a use case where people have these kind of like routing points, or they're not really routing points. I don't know exactly how to describe them. They have like a model that's like a sphere, and they have bundles routing to these different spheres. And so you could kind of see how that functions similarly to a splice. The answer to the question really, though, is either one will work, right? If we have a splice already placed in the model, as long as that splice is designated, we can use that as a from or a to location of the route. So no problem if the splice is already in the model. Obviously, that's no surprise. But like I was mentioning with the capability via AutoAssemble to assemble the connectors as a part of the auto routing process, we can do the same thing with splices as well. So in that scenario, the splice is kind of just treated as a connector. There are a couple different ways to insert splices in Creo cabling. You can use the insert component option to route a splice like with or add a cabling location that already exists and route through that splice, or you can place a splice, designate it, and route to and from the entry port coordinate systems. Either one of those is supported with auto routing.
All right, got another one. So you don't need to set entry ports on connectors?
Yes, so good question. If I were to, I'm not sharing my screen. Well,
go ahead, you can share.
Okay, so I'll open up one of these connector models. This is a part of library definition, and this is actually something that you can use with or without our tools. This is just a part of Creo cabling functionality. So on this model, there are a whole bunch of these coordinate systems that are all intended to be used as entry ports. Let's see if these are set up properly. These actually are not even set up properly. So yeah, we are handling this and being able to route to and from these, even though they don't have the proper parameters on it. But what I was going to say is, this is the part that's just native Creo cabling, whether you're using our tools or not. if you go to these coordinate systems that you want to be using as entry port coordinate systems, you can create a parameter on here that is entry underscore port, set it to a Boolean, so a yes, no, and then we set this to be yes. Because this coordinate system has a feature parameter on it, so these parameters are on the coordinate system feature itself, not on the model. This coordinate system can have this entry port parameter on it set to a value of yes. And now, because that's there, if I were to use this connector in an assembly and designate it, I'm sure you're referring to the normal process. You designate that connector, then you say entry ports, and you have to go control select all of the coordinate systems that you want. And then you set like an internal length if you want, all those other things. You can, having that parameter on, that feature parameter on this coordinate system bypasses all that. So Creo, when you designate this model, this connector model, it will find that parameter on the coordinate system, and it will automatically understand that this is supposed to be used as an entry port. We can also have other parameters. You can have an internal length parameter here. You can have a grouping parameter here. You can have a pins parameter here. There's a whole set of feature parameters that we can use on here that will automatically propagate information into your model where this connector is being used. So I guess that was a long-winded answer, but in summary, we obviously don't have to have that parameter there to use it, but that's just kind of typically a good idea as a part of your library management process. When you bring in connectors, you add these parameters, these feature parameters onto those coordinate systems, and it can speed things up for you down the road.
All right, got a few more for you. For the routing rules, can we define specific clearances we want to keep away from other component hoses or tubes?
Okay, that's a good question as well. The way that we are set up today, so we can provide information to these routes that is, it's a couple parameters that we're using that are called use path and required path. So what we are saying with those is, as you're evaluating the route for this wire, we want you to try, if you're using use path, it's saying we want you to try to use anything that has a naming convention that looks like this. Or required path is saying, I don't care where it is, if it has this naming convention, you have to use this as a part of the route. So the idea here being that, you know, I think of one of our use cases that a customer is doing. They have certain areas where there's like door wires versus paths that are supposed to be used for power cables, and you know, AC versus DC. They have things like that set forth in their model. Another a good idea would be like, if you have a cable tray or something like that, that would be a good idea to use that in a use path. Say, use any cable trays, essentially. Any of this information that we can provide into the model or into the algorithm, it's going to help make the route better. So in this case, I basically said, like, try to use clips. And so it's routing through all these clips, the ones that make sense for the particular route. But in terms of interference detection, that is actually something that we are still working on adding. It's not a part of it today, but it is a feature that's coming soon. So we are currently working on developing that.
Okay. How are markers and heat shrink tubing applied?
So as of today, we don't have any mechanism for adding markers or heat shrink. That's definitely a good idea and something that we could tackle in the future. It's not something that anybody who's using the tool today has a requirement for, which is, you know, why it doesn't exist yet. But yeah, that's certainly something we could have a conversation about and see how much effort it would take to get there. But yeah, not a part of the tool today.
That's an example of bring us one of your problems, we'll create the solution.
Yeah, absolutely. And actually, just to tack one more thing onto that answer too, it reminds me something that I think is a good point to bring up here. Now that we've run auto routing, these are just normal wires as if we had created them manually. So like if you need to go tweak something, there are cable locations that exist here. We can just open the cabling application and edit any of these routes the same way you would if this was made manually. So markers and heat shrink like that, if even today, as it's not a part of the application, I could still just open the cabling application and add some heat shrink here. There's no reason that I can't do that.
All right. Right now we have 3 more questions. Can we create a flattened version of cable harness? And if yes, is it automated?
Yeah, absolutely. That is not something that is in our tool set, but that is just, we hand that off to Creo out of the box or virtual interconnect. So there are 2 different methods for flattening harnesses. There's the manual way, where you just come into you say like file new, you can create a manufacturing harness and flatten it using the out of the box tools that Creo has. Or the automated way would be using virtual interconnects tool, harness manufacturing extension, HMX. That is an additional license. It's an extension that needs to be purchased, but they basically allow you to kind of click button, get flattened harness, rather than having to do it the manual way with Creo out of the box. So multiple different options.
Yeah, one thing to add there is that HMX tool is super powerful, but it's not going to work well unless you have these things routed in the right way, right? In a scalable best practices way. So, if you're hacking together your cabling designs, then it's going to be harder to automate using HMX, right? What we're making here should be out of the box, click button, use HMX, get drawing.
Okay. How do you manage the copy geometries?
Yeah, okay. So this is actually another part of our tool set. You see that we have the geometry publisher and the geometry copier here. Really, our auto routing tool kind of takes a whole bunch of things that we already had before and uses a bunch of them in succession to get us to this point. And then the algorithm part is the only like new part that we added specifically for auto routing. But the first part of this, right, when we're creating the copy geometries, it's just using tools that we've had for years and years and years. And let's go look at that. So, sure. We use published geometries. So again, this is a part of library creation, right? We have a connector that we are bringing into our library. As a part of that process, we want to do a bunch of things, right? We want to set it up in our start part. We want to make sure we have certain datum, certain planes and coordinate systems. We want to add the entry port coordinate systems. We may want to add certain parameters and simplified reps and orientations and all that stuff that's a part of bringing this in and calling it a good model in your library. What we recommend there is just adding one more step to that process, which is publishing important critical interfaces or datums within the model. So in this case, there are a couple of coordinate systems here, entry 1 and entry 2. We have published both of those coordinate systems. And all that's doing is stating that we know that these are important things and we're going to care about them later. What that allows us to do then is create a lot more automation. If people are used to using published geoms and copy geoms with just Creo out of the box, when you're creating copy geometries, they allow you to just select a published geometry and then it will create a copy from that published geometry. We're using it within our automation to flag something that's important. So if we have anything published on here, we know that that's an important thing that should be considered whenever we're creating our copy geometries. So come back here, what does that mean? That means that we look at every single designated model, and that's how these groups are named, right? This is all per, turn off this so that it looks a little clearer. Per model, we have one group, And inside of those groups, which one do I have open there? Okay, well, whatever, this is fine. Inside of that group, it's all of the copy geometries that are relevant to that one model. We create one copy geometry for each published geometry that exists. So this model has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 coordinate systems that were published. Therefore, we create 10 copy geometries to match one-to-one with those published geometries.
All right.
Hopefully that fully
and
answers the question.
it's an implementation question, really, right? It's a setup. We do that one time with your catalog parts, and we can use that moving forward.
All right. Last question. Can the routing rules be altered on the fly?
Yeah, so on the fly, like when you hit go and it's routing the like actually running through the algorithm, there's no way to like change things on the fly while that's happening. But what we can do in our auto routing interface here, I'm going to select my harness assembly. Now that all of this has been created, whenever I select that harness assembly, it's like scanning the assembly and it's going to populate down here with all the stuff that exists inside of it. There we go. So it's reading all this information in now from the model, not from an input file like it was before. But what I can do, if I right click on, oh, you know what? This might be, oh, I'm using a previous version of this code, but we have a newer build of this where we have already integrated this in. I was just trying to use something that I knew was really stable. But basically, we have an updated build where we have already tackled this problem. And basically, in my list here, there's all this information about this particular wire. Like we have a status, right? Routed status. It's a green icon here to tell me that, yes, this is routed. The path status, yes, it has a path. That has been solved for by the algorithm. Right now, our red icon here, which this one red icon here is leading to the overall status icon to be red. That's red because it's missing logical data. Well, that's just because I haven't input that file. Like if I go in here and I input my auto routing file now we see that status has gone green. Oh, yep, okay, now you've told me where that input file is. I can actually verify and check that against what's in the model. The green indicator here, that tells me that the logical data matches what is in the actual model. So that is what this first part is. Then we have our route info. This is telling me where's my from, where's my to, what's the spool that's being used. I can edit any of these on the fly. We have the path info. This is what I was talking about with use path or required path. We can also have specific included or excluded nodes along that path. And then finally, we have our settings down here. So on the routing settings over here, this is for everything. I also have the ability to come through and specify on a per wire basis what I want these the routing profile or the specific settings to be. Now, sorry, all of that to finally answer the question that you actually asked. In the newer version of this code, which I am unfortunately not running right now, when you right click, there is an option to preview the path. So if all the information is there, right, we have the route info, the from to, we have the the logical data, which would provide us with any use paths or required paths or all those things. If I were to right click and say preview path, it's funny, the thing that takes the most time when this is running is actually creating the wire features and connecting it, routing it through all the points. The algorithm solving itself is pretty quick. So that is what the preview path is doing. It only will do the algorithm, and then it just kind of shows you a preview of what that route is going to look like in your model. So that would be what I would consider to be on the fly, right? You bring this in, and before you actually hit go, and it has to solve for and create all of the features, which that's the part that takes the most time, you can first preview the path. It'll show you what it looks like, and you can kind of decide, is that good enough or is it not good enough? And then tweak your settings, and then preview again, tweak your settings, preview again. That would be the process that I would recommend as of right now. Another thing that we have talked about and are working on is kind of modifying, still not necessarily like on the fly as it is creating the route, but being able to show that preview and input your feedback basically on the route that is being previewed to provide, like, actually, I don't want it to go through this clip. I want it to come down here and go through this clip. So being able to apply or provide that information while you're looking at the preview is something that we are also working on adding to this and should be coming.
Okay, we had one more question come in, and we'll make this our last. We have 7 minutes before the next hour, and we want to get people moving on to their next obligations. So, are drawings automated as well? And what about MBD?
Yeah, so the drawing automation for auto routing specifically, that tool really only encompasses what we've seen here today, right? It can create a subassembly structure. It can do the skeleton with the copy geometries. It can assemble connectors if you want, and it can solve for routes and create these wire features. All of that is encompassed in auto routing. The flattened harnessing part, the drawing part, that is all something that we consider not to be under the auto routing tools umbrella. However, like I mentioned earlier, we don't touch anything on the harness flattening part of it. We do have some options on the drawing automation front. These are just different tools that we have in our tool belt that, I guess I'll go into it a little bit. Under our standardized option, we have Model Builder. So that's really what we're talking about when we're wanting to work on like drawing automation. So inside of our web application, we can set forth a drawing template. We can add any number of parameters, or there's all sorts of things. We can do this with parts, assemblies, or drawings. Actually, it's not just limited to drawings. But we can use that automation to create these things on the fly. So is there auto routing functionality to automate the creation of the drawing? No. Do we have that covered in other parts of our application? Yes.
All right. Well, at that, we're going to wrap up today's webinar. We'd like to invite everyone to learn more about ETRAGE software and service solutions from our past webinars. You can visit etrage.com. And we invite you to reach out to us and have a deeper conversation, whether it's about today's topic, with our friends at CadActive, or challenges that you're having around your systems, your management, or your software end users. A reminder that we will be reaching out and sending you a link to today's recording so that you can either rewatch or share with your colleagues. And I would again like to thank CadActive, Phil, and Ben for sharing your expertise with us today. And I would like to thank all of you for attending. And we will see you next time.
And I just want to mention, I did not address the MBD part of that question. I'm typing up a response in the chat right now, but yes, we support all aspects of MBD within our standardized tier as well.
Ben,
so,
we can
yeah.
send that out. We can send that answer out with the link to the recording as well.
Okay, perfect.
Thanks, everyone. Have a great day.
Thank you, guys. Yep.